multiply and divide in rational expressions, if you remember that rational is basically a fraction, right? So in order to be successful in multiplying and dividing rational expressions, you need to review how to multiply and divide fractions. Okay, so this is what we're going to do. So multiplication and division of fractions, because if you are good with in it, it will be a great there is a great possibility that you'll be successful in this lesson as well. So the multiplication and division of fractions. Okay, and I'll need your help now. I will design a couple of questions. So for example,
Which page is this?
there is no page, like just what I'm doing is not related to this question. Okay, so I'm doing a review of the multiplication division of the fractions. So I'm going to design a couple of fractions for you to multiply. So let it be something like that. First, very simple. So if you need to multiply without the calculator, this is what's important. If you need to multiply these two fractions, what will you do? Who knows? Without the calculator. Don't tell me that nobody knows. Noor, do you know how to multiply fractions?
Miss, we multiply the numerator and the denominator, like 2 times 5 and 3 times 11.
Absolutely, absolutely. So to multiply the two fractions, we need to multiply numerators and denominators. I hope that this now you remembered it, because if nobody knows except for Maya how to multiply fractions, then we are in trouble.
Yes, I know.
Yeah, so the final result is going to be 10 over 33. Now, let me give you another example, which is less straightforward. For example, I want to multiply 6 over 5 by 10 over 24. So I want to ask you, can I simplify the fractions before multiplying?
Yes.
If yes, then how?
Yes.
It will be one
How?
over two.
It
How
can
can
be.
I simplify the fractions before multiplying?
I mean, yes, yes.
Yeah, miss.
Yes,
Yes,
is I'm asking how to simplify them before
we're gonna
multiplying.
simplify 5 and 10.
Exactly. So you can check across always like this, right? So if you check 5 and 10, so you know that it can be cancelled. So 5 is cancelled and
Can be 1.
10 is going to be 2. Yes, instead of 5, you're going to write 1. Instead of 2, you're going to write 2. What about 24 and 6?
Gonna be 1 and 4.
Absolutely, 1 and 4. Okay. So now, instead of multiplying all of this, I just need to multiply 1 by 2 and 1 by 4. In fact, I can see now that I can simplify even more, right?
Miss,
What else? Yeah.
One over
So I can multiply, simplify this with this, so it will be 1 and 1. So my final result here is 1 over 2. Okay. So this is very important. We're going to do the same thing, but with the rational expressions. From yesterday's lesson, you, I hope, remember that expressions means that we'll have a variable in the fraction. Okay, now this is multiplication. Multiplication is pretty easy. This is multiplication example. Okay, now we're going to do the division example. You can keep thinking about it while I'm while I'm designing a fraction. I'll take the same one, which is, for example, 2 over 3 divided by 5 over 11. So who remembers what to do first? What kind of access step do we have in the division?
We flip the second fraction.
Absolutely. We flip the second fraction. And what else do we do? What happens to the sign, the division sign?
Make a multiplication with
time.
We add a multiplication sign.
So we replace the division with the multiplication and flip the second fraction, right? After that, you just follow the multiplication steps, right? So, Ismail, what will be the final result here?
It will be 22 over 15.
Yeah, okay. Now, one more example, and we'll move on to the rational expressions. What if I have, like I had here, something which in fact can be simplified? Let it be, for example, 3 over 10. Okay, what is important is that, do you think I can cancel out 6 and 10 right now? I mean, not cancel out, but simplify 6 and 10? Yes or no? Can I simplify 6 and 10?
Yes. 3 and
Okay,
5.
so yeah, so no, the answer is no. Why? Because for the division, we have to first do this exchange with the multiplication and flip. You can cancel only when you have a multiplication between the fractions. Okay, you cannot cancel when you have division, because what will happen now? We're going to replace division with multiplication and flip the second fraction. So it's going to be 10 over 3. So it's totally different. So now we're going to cancel.
Miss, the answer will be 2.
Good,
Oh.
but I want to know how. I don't want calculators.
It's gonna be 2 and 1, and
2
10 is
and
gonna
1.
be 2, and then the 5 is gonna be 1. It's gonna be equal.
So looks like the answer is 4
Yes, 2
over
times
1. What is 4 over 1? Which is 4.
4.
Not 2. Okay. So this information is, or this skill, I would say, which you hopefully gained in elementary school. This skill is crucial for today's lesson, because today we are going to multiply and divide the rational expressions. So basically, to multiply the rational expressions and to divide the rational expressions, you will need to always first factor the numerator and denominator, which is exactly the same thing like what we were doing yesterday. Okay. Then right after that, you will need to, it's not mentioned here in the steps, unfortunately. What did we used to do yesterday after factoring? What is the second step right after factoring? Restrictions. It's very important. Right after factoring, you set restrictions, because otherwise, later on, while simplifying, you will lose them. So you will do the restrictions, and then you will simplify, and then you will multiply numerator by denominator, and so on. What I'm going to do right now, I'll take examples from here. One example for multiplication, one for division. And I will write down everything in steps. So please take notes of those steps. So we're working with these questions. It's now, someone was asking for the page. We'll start with page 121 from 1 to 3. And the rest is here. You can, if you want, you can write it down now. Page 122. Write it down, the practice. All right, so page 121 from 1 to 3. I would just like to check if Sarah. Okay. Sarah, are you at school or at home? Спасибо, Mohammed. So Sarah.
Miss, I think Sora just left the meeting like a minute ago.
Okay. How about Hassan and Hanin? Do you guys hear me? Okay. All right, good. Right, let's start. Okay, I'll keep it here because you know that I post solutions afterwards. So this is the range of questions.
Miss Hanin replied in the chat.
Yeah, I saw it. Okay, so guys, we're going to do 3. In 3, we have 1 multiplication, 1 division. Okay, so we'll do each example in detailed way with the steps. So let's do 3A. As an example of how to work with rational expressions when you need to multiply them. Okay, so as you remember, the first step is, tell me the first step.
Factoring.
Yeah, so you need to factor all numerators and all denominators that you have. So check the first expression. Do you need to factor numerator?
Yes. No.
No, it's already in factored form. How about denominator?
Yes, you need to factor it.
So you need to factor denominator. So the first thing we are going to do is to factor denominator of the first expression. Okay, please, your suggestions for factored form.
Miss X minus 2 and X plus 1, I think. Or X minus 1 and X plus 2.
Other suggestions? Multiply, it should be multiplied to, the 2 numbers should multiply to
I mean
the last
3, I
term.
mean 2. So X minus 1, X plus 3, or X minus 3.
X plus 3. Yeah, correct. Okay, so we factored the denominator of the first expression. Now let's check the second rational expression. The same, right? The numerator is factored, the denominator is not. So let's factor the denominator. Your suggestions, guys, for factored form. Anybody, please.
X
Multiply
plus 3, X plus 3 and X plus 1.
Okay, X plus 3 and X plus 1. So the final step in the first step, which is factoring, should be writing the both rational expressions which are multiplying in factored form. So X plus 1 squared over. Now instead of this expression, I'm going to write X minus 1 times X plus 3. Then times between the 2 rational expressions, and the second expression is X minus 1 squared, and denominator is X plus 3 times X plus 1. Okay, so now my question is, what is the second step?
Set restrictions.
Absolutely, so set restrictions. Okay, think about 1 minute. I'm giving you 1 minute to think about restrictions.
Miss Talia.
Okay, any suggestions about restrictions?
I think it'll be 3 is will
So
not be
x should
equal.
not be equal to,
Oh,
and
yeah.
then you list restrictions.
X should not be
1,
equal to 3, I think.
1. What else?
-3 and
Negative
-1.
3.
And
-1.
1 and positive 3.
-1. Okay. Who needs clarification and restrictions? Because if everybody understands, I'll just move
Yeah,
on.
me, I do.
I don't understand
Okay.
the restriction part.
Okay, who would be able to explain how we got these restrictions? Noor, can you
I
try?
think I can.
Who is that? Noor, right?
Noor, yeah.
Yes, can you
So
explain how you got
basically-
1, -3, and -1?
Yeah, basically, I looked at the denominators and I was looking for the numbers that would not make the denominator 0. So if I replace the x in the very first denominator with 1, it will be 0. So if I multiply 0 by the next equation, the whole denominator will become 0. So therefore, it can't be 1. So this is the first restriction. And then I substituted -3 in the second equation, and I did the same thing. So it will become 0 again. So it can't be. This is the second restriction. And then in the other equation, I substituted -1 in the second term, and it also made the whole equation 0, so I couldn't use it.
I have a question.
Yes.
Why didn't we include -3 in the second equation? -3 plus 3. And
We wrote -3, which can work for both.
Yes. Well, just you don't repeat it. You list all the restrictions. Yes, in both cases, Farah, here and here, the restriction is -3 because they are zeros. Let me remind you, zeros of both, in this case, denominators. Okay. So,
okay.
any other questions about restrictions? Okay. So now, what do you think we are going to do next after that?
Simplify.
Absolutely. So at the next step, we can simplify. And when you simplify, you can think, you should think in both directions. Simplify the expression itself. Maybe it will be possible. If nothing, then check across, right? So simplify. So tell me, okay, I'll have to rewrite it because I really want to make the notes organized. So this is what we have. You, meanwhile, think about what we can cancel out. Times x minus 1 squared over x plus 3 times x plus 1. Okay, so I'm waiting for your suggestions now for what can be simplified. We're checking across numerator with the denominator, numerator with the denominator. Just like we did in the fractions here.
The x minus 1.
So x minus 1 here, and here it's the second power, right? It becomes first power.
Yes.
Here, instead of x minus 1, we'll have 1.
And
Good.
the x plus 1.
Same goes for the x plus 1.
Same idea with x plus 1. Now, can I cancel x plus 3 and x plus 3?
No.
Why?
Miss, how can you cancel them if they're both in the denominator? You can only cancel them if you flip it. But why would you flip it?
So it's not across, you see? We're checking like this and like this. So if something is similar in this denominator and in this denominator, you cannot cancel them. So you can cancel only numerator with denominators. Okay? So after we simplified it, let's write the simplified version of this. 1 over x plus 3 times x minus 1 over x plus 3. Correct? Agree?
Miss, I don't understand why the 1 is over the x
Okay.
plus
Was
3.
it 1? Was it not?
Guys, one by one. The first person who said who doesn't understand why is it? I made a mistake. I made a mistake. It's x plus 1. Of course, because here we cancelled only the first, only the one of them, right? There are 2 of them multiplied, so we cancelled 1. Okay. Any other questions about this part?
Miss, I didn't understand the cancel. I don't understand the part of like canceling. Like, why did we cancel x plus 1 and x negative 1? I don't understand.
Do you see this x plus 1 and here x plus 1? Do you see this?
Yes.
So across, so numerators can be simplified with the denominators. Here x plus 1 is once, so the first power. Here x plus 1 is twice because it's the second power.
Oh, yes, I understood. Okay.
Okay,
Thank you.
same idea with x minus 1. Any other questions, guys, about the part we simplify? If no questions, then we can move on to the next step. So what do you think is going to be the next step? What's left? We remember what we are doing? We're multiplying.
Multiplying.
So basically, finally, we can multiply. We already simplified.
Oh, yeah, yeah.
So multiply. And multiplying is exactly same way as fractions. Same way as fractions. Right? So we multiply numerator with numerator, denominator with the denominator. So what is going to be the final result? Selim.
Miss,
Selim, yeah.
can
What
you
is
hear
it
me?
going to be?
Miss, I got back home and I don't really understand what happened. Like, I
Okay,
went
fine.
from you guys multiplying fractions, and then I came back home. I found you guys doing this, so I don't
Okay.
really know what's happening.
Right. Okay, so focus in the division, which we'll be doing now. The big part is multiplication part. So focus, try to catch up. Okay, Farah, what's the final result? Farah?
X, like, Miss, are we gonna multiply the 2 brackets?
Yes.
Like the 2 x to the power of 2, negative
By power of
x.
2. No, you don't expand. Just multiply this by this.
So x plus 1, and then bracket x negative 1.
Exactly. And then down?
Down x plus 3 in the bracket, and then the other bracket x plus 3.
Exactly. Now, to make
We
it
can't
look
write
nicer,
x squared.
that's what I'm saying. To
Okay.
to write it nicer, which means shorter, you should think about the pattern here and here.
X plus 1 and
What is x?
x negative 1, then x power 2.
Yeah. What is this? Plus 1, negative 1. What is this pattern?
Yes, negative x, and then plus x.
No. Guys, what is this pattern?
It's gonna be
X plus
minus 1
Minus
because
1,
it's
because
difference
it's a,
of squares.
absolutely. Farah, do you remember difference of squares?
Oh, yes.
So I can write it like this. And Noor was suggesting how can we write denominator?
X plus 3 squared.
X plus 3 squared. Okay, technically, this answer is already correct. You have multiplied. Okay, here it's just we make it look nicer, which means shorter. Okay, but this is already the result of multiplication. Okay. Okay, so the next question what we're going to do is division. We'll take the division from question B. Just 1 second. Okay. Division. Mm-hmm. 2x plus, I'll write it here down so that I can, well, 2x plus 10 over x squared minus 4x plus 4. So we're moving to division now.
Miss,
Mm-hmm.
I have a question. So when you said you want to make it look nicer, so did you factor here or what did you do?
Just a second. Plus 4. Here I wrote it x plus 3, x plus 3. Instead of writing it 2 times, I can write it as raised to the power of 2. It's not factoring. It's knowing what's exponents mean. So I can write something which, instead of repeating it, I can write it to the power of 2. Okay?
Okay, miss.
Here as well, instead of writing, you see, 4 terms with the 2 brackets, I know that this formula represents difference of squares. So I can write it as 2 terms. This is already factored. Of course, I did not factor, but I replaced it with another equivalent expression, which is shorter than this one. Okay, so divided. So divided by x squared minus 25, x minus 2. X minus 2. Okay, so what's the first step? Always.
You multiply. You replace the
No.
division with the multiplication.
No.
Factoring?
Factor. The first and the second step will be always the same. Okay. Okay, so Selim, can you factor the numerator of the first rational expression?
The one 2x plus 10, right?
Mm-hmm.
We could use I don't know what we can use.
Just tell me how it looks like.
Greatest common factor. So 2.
Yeah. Yeah.
2 and then bracket x plus 5.
Yeah. Good. Guys, what about the one at the bottom?
We can use greatest common factor also.
First, yeah.
So 2.
Mm-hmm.
And then x squared minus 2x plus 2.
Okay, now when I got this expression, do you think we can try to simplify it more?
Yes, Miss Week. I think we might.
Although I'm not sure. Okay, so guys, can you try if simple trinomial is going to work?
Miss, I don't think it's going to work because the
same number.
You know how to check whether the simple trinomial or complex trinomial is factorable? Does anyone know? How? I'll tell you now another secret, which I didn't tell you before. It's again mod 5.3. So if you go to mod 5.3, and because factored form is basically what? X minus first root and then x minus second root, right? So if you go right now to mod 5.3 and try this trinomial, try to search for the roots and check what you got. If you got irrational numbers, I, not irrational, sorry, imaginary number, I, it means that it's not factorable. Can you do that? Did anyone manage to do that?
Yes, for the bottom one, I got 1 plus I.
Yeah. So it means that there are no real roots. So this one cannot be factored anymore. Although it looked as if it might be possible to factor it. So let's factor the second rational expression. Emre, can you factor the numerator of the second rational expression?
Okay. It will be first. It will be x, like greatest common factor.
Definitely.
No, Miss, we can use difference of squares.
Of course.
X plus 5,
So
minus 5.
exactly.
X plus 5, yeah.
X minus 5. What about, guys, the denominator? Do you think you can factor it?
No.
No, we can't. Yeah.
Yes,
Look, I have
I'm
now.
sorry, my
I
Wi-Fi is
suspect-
really bad.
What?
My Wi-Fi is really bad. I can't really hear you. This is why.
Okay, anyways, I'm recording. So, guys, I have a question. Does anyone have a textbook with them? Now, because I started suspecting something.
Yes,
I
Miss.
have a feeling that this is wrong because some PDF, could you check this on the
Page what?
one
121.
21, right?
Yeah, I'm checking right now. Question what, Miss?
3B.
3B. Yeah, it's x. It's x squared.
Minus 4x.
Minus 4x. Yeah, it's right.
It's right, plus 4. Okay.
Yeah.
Oh, wait. I am the one who copied it wrongly, right? I copied 2.
Yeah, Miss. It is 2x plus 10.
No. 2 down. I
Yes, it
copied
is
it wrongly,
down.
guys. Yeah, I'm
It is.
sorry. I copied it wrongly. Okay, so let's correct it. So now it will be factorable. You understand what I mean?
No, Miss. I don't know what you did there.
No,
Look,
miss, I don't know.
here.
put a 2
There is no
below
2
it.
here. There is no 2 here.
Ah.
Because I copied it from when I was copying, I made a mistake. So let's try again. How can I
Miss,
factor?
but when you wait, Miss, I'm kind of confused. You said that we would use greatest common factor.
Now we can't
This
use
is
greatest common
why you
factor.
put a
Now we can't because there is no 2 here.
Oh, okay, yeah, okay.
Okay, so let's guys think about the pattern. What is it?
Simple trinomial.
It's a perfect square.
It's a perfect square. So Maya, how can we factor it?
It's gonna be x minus 2 squared.
Correct. If you are not good at perfect squares, you can still do simple trinomial, right? So 2 numbers which multiply to 4 and add up to -4. So it will be -2 and -2. Okay. Yeah, this looks better. Now, please, I want your full attention because when we reach the second step, it's for the division. The second step is going to be slightly different. So you need to set restrictions as before. For which parts of this expression did we use to set restrictions for?
Denominator.
Only denominators, but set restrictions for both denominators. This is what we already used to do. Denominators. But here, because it's a division, we need to think about something else. Can you guess? Where else should we think about restrictions?
Numerator?
Of which numerator? Maya.
The one on the left, Miss? I don't know, I'm guessing.
Yeah, Maya, what do you think? Which numerator? The first one or the second one? And why, of course?
I don't know, Miss. I guessed for the first part, I guessed.
Yeah, okay, so but that was correct. For the numerator of the second.
I think the second one.
Of course. Why do you think? Of the second expression. Always.
Because the first one has x plus 5 and the second one has x plus 5, so they're common. So we're only factoring x minus 5.
No. This is a general statement. It doesn't matter how the functions look or the expressions look. It will be always true. Why? Because what will happen when we try to divide them? What will we do to the second expression?
Miss, I don't understand.
What do you do when we were doing the fractions? What did we do to the second fraction?
We
flipped it.
We flipped it. So it means when you flip this expression, what will happen to the numerator?
It will become
Where
the
will it
denominator.
be? It will become denominator. Okay, that is why it's only in the division of two rational expressions you need to set restrictions, not only for the both denominators, but also for the numerator of the second expression. Okay, so let's do it. So what are all the restrictions? Of course, you should look here
Miss X cannot
and
be equal.
here, because setting restrictions in factored form is much easier than when it's not factored. So what are the restrictions? Just a second, Noor. I want to ask Selim. So if you look at this denominator, what should be the restriction?
X cannot be equal to 2?
Yes, good. Farah, what should be the restrictions when you look at this numerator? Farah.
X should not be equal to -5 and 5.
Exactly. And what about the last thing, this denominator?
It can be X can
be equal
to 2.
Which is already listed. So you don't need to repeat it. So bottom line, we have 3 restrictions here. +2, -5, +5. Guys, do you have questions about this part?
Yeah, Miss.
Please.
Are there restrictions for every variable in the denominator and the numerator?
Well, you will always have one variable only. This is one thing.
Denominator.
Sorry?
He's asking if it's for both numerator and denominator. It should be only denominator.
Okay, and the second part is for the division, you do both denominators and the numerator is written here, the numerator of the second expression only. You do not think about the numerator of the first expression. Don't care about it. You need to think only about the numerator of the second expression. Why? Because when you flip it, it will become denominator. So that's why you will have to exclude the zeros for the numerator as well. Any other questions? Yeah.
Both denominators and numerator for the second expression.
Exactly. This is exactly what I wrote here. Yeah.
Okay, perfect.
Right, let's move on. Okay, so we have factored, we have set restrictions for both denominator and the numerator of the second expression. What do we do next?
Simplify.
Okay, to simplify, you have to have multiplication between them. You remember I told you when you have a division of 2 fractions, like here, you cannot simplify across because you can simplify only when they are multiplied. That means that the first thing you need to do is replace the division sign with multiplication sign. Well, with multiplication sign, and what do we do next if we already replacing division with multiplication, guys? Flip what?
The term.
Which one? The second rational expression, which is the second fraction, right? The second rational expression. So let's do it.
Miss, I have a question. So when you say, like in step number 3, you say flip the second rational expression, and step number 2, you say the numerator of the second expression. This is only for this question. It's not always the second expression, right?
Why? It's always the case. Because if you divide, you always divide 2 things, one by another one.
Okay.
So it is.
So this is like a rule, right?
It's a rule. All of what I'm explaining now, it's a rule which was like an algorithm for you to work with any rational expressions.
Miss, this is for anything when we're multiplying or dividing?
Dividing, you see division.
Okay.
Division. Okay. So let's do it. So the first rational expression in factored form stays the same. We don't do anything to it. Now we replace the division with multiplication and flip the second expression. So x minus 2 will go up. And down we'll have x plus 5 times x minus 5. Okay, so we have done that. So now, what was Maya suggesting before? What are we going to do next?
Simplify.
So, yeah, basically, I can say that now, from now on, follow the steps of multiplication. Right? Because it's multiplication of multiplication. Multiplication. Okay, so first we're going to simplify, and then we'll multiply numerators and denominators. Simplify. Again, I'm doing this first and the only time in a very detailed way. And you will not have to do this every time like this. Once you get enough experience, you can make it shorter. Okay, so your suggestions about what can be simplified? Anyone?
Miss,
Yes?
the -2 and the x minus 2
Squared.
Again,
squared. Yeah,
repeat.
cancel 1.
So x minus 2 is cancelled. What will be left here?
1.
What about this?
There, x minus 2 is going
Minus
to
2 without a square.
without squared.
So the first power, absolutely.
Yes.
Guys, what else can we simplify?
X plus 5.
Mm-hmm.
And then cancel x plus 5.
Yes. So let's write it in simplified form. Just a second. I want Ismail, can you? It's simplified form of the first one. Zaina, can you hear me? Because you did not respond to me today. Zaina, can you do it? Asli? Emre, can you do it? Okay. Selim?
Do what, sorry?
So I need you to tell me what's the simplified now form of the first rational expression. What will be left in the numerator?
Just 2.
Just 2. What is going to be left in the denominator?
X minus 2.
Yes, x minus 2. Now the second fraction, Adil.
1 over x minus 5.
1 over x minus 5. All right. So after we have simplified, finally, what can we do? What's the next step? Emery. After we have simplified the expressions, what can we do finally?
Restriction, I think.
Really? And what did we do at the second step? Look, what did we do at the second step? So number 5, someone said it.
Now
Could
multiply, miss.
Multiply. Finally, we can multiply.
And miss, when we multiply the rational expression,
Yeah.
we multiply normally.
Normally, numerator by
like
numerator.
how we multiply fractions.
Fractions,
It's
absolutely.
2 over x minus 2, x minus 5.
Yes, so 2 over x minus 2, x minus 5. And I want to tell you, factored form is the best one. I want you to remember this forever, for this year and for the next year. So do not expand. Even if you see the answer in the textbook expanded, I'm telling you don't expand, because factored form is the best of all forms whenever it comes to using it in word problem and so on. So this is the final answer. Any questions about the steps? If no questions, I'm going to stop first of all recording, and then I'll tell you what we're going to do next.
Miss, if possible, can you post all these notes on Google Classroom?
Yes, of course. I always do that, right? I will.